Earlier in class today, we did lesson 1-5 and try it for example 2. And what we did was we graphed the parabola x squared plus 6x plus 5, and we were looking for when that graph was greater than or equal to 0. So looking at the graph here, you can see that it occurs to the right of -1, or it also occurs to the left of -5. So these were the two intervals where we had good solutions, where the graph was above the x-axis or positive. A couple kids today wondered how we might solve something like this algebraically. Similar to part B, I added 3x to both sides, and then take away 3 from both sides. And then when you divide both sides by 4, you could see that that's when x is greater than 1. That's pretty straightforward. You're just adding and subtracting and keeping the inequality going the same way. In a quadratic like we have here, this is a bit advanced, but if you recall from maybe Algebra 1, we can factor this into x plus 5 times x plus 1 greater than or equal to 0. So again, that's called factoring, and perhaps you remember this foiling where you do first times first to get x squared, outside times outside to get 1x, inside inside to get 5x, 5 times 1 makes the 5. So this is the factored form of this parabola. From here, we want to think about how we would get two factors if we call this guy A and this one B, how we might get A times B to be positive or greater than or equal to 0. So if we think about it, for two factors to be positive, we either want them both to be positive, that would give us an answer greater than 0, or we would want them both to be negative to get an answer that's greater than 0. Okay, greater than or equal to 0. So what I want to do here is I want to make a couple cases where I want x plus 5 to be greater than or equal to 0, and I want x plus 1 to be greater than or equal to 0. That would be case 1, where both of those are positive, and you have a positive times a positive equaling a positive. The other one would be if both x plus 5 was less than or equal to 0 and x plus 1 less than or equal to 0. So in this case, we have both factors being negative times a negative equaling a positive, which would be greater than 0. Okay, so these are the two cases that we're going to solve, and I'll explain a little bit more in a moment. In this one, we simply take away 5 from both sides, so you get x greater than or equal to -5. Don't forget we have and. X is greater than or equal to -1 after we take away 1 from both sides. So keep in mind, this is and, meaning both of these have to be true. So if we think about x being greater than or equal to -5 and greater than or equal to -1, if you think about a number line, right? If we have greater than or equal to -5 and greater than or equal to -1, where do the blue and the green both exist? And that is here, when x is greater than or equal to -1. That is the solution where both of these are true. That goes back to this. Greater than or equal to -1 was 1/2 of the solution here. The other half comes from looking at solving this, subtracting 5 and subtracting 1. X is less than or equal to -5. and x is less than or equal to -1. So in this case, on a number line, we think about -5 being here and -1 being there. Where would the overlap be? Where the blue, we're looking at less than or equal to -1. And the green, we're looking at less than or equal to -5. Where do you see both colors? Here, to the left of -5. So this is the other half of the solution. This is the right half of the solution that we saw on our graph. X is less than or equal to -5, or x is greater than or equal to -1.